Guys, so in today's lecture we are going to start a new chapter, that is fuel and its supply system. Fuel and its supply system for SI and CI engine. So for spark ignition and compression ignition engine, we are going to see fuels and its supply system. So today, today first one or two lecture. Today we are going to discuss about fuels for SI and CI engine, and in the later lectures we will see the supply system. So today let's discuss fuel. So in the main topic of fuels we are going to discuss that important qualities of a IC engine fuels and rating of fuels. So what are the important qualities that are required for internal combustion engine fuels? So it may be SI or CI. So let's see one by one. So let's start with SI engine. So qualities required for SI engine fuels. Qualities required for SI engine fuels. So for smooth running the internal combustion engine, fuel should be possesses certain basic qualities. So for a spark ignition engine, we generally use gasoline, the major product of the petroleum refining process and mostly used in present day SI engine. So two advantages of use of gasoline are better rate of burning and easy vaporization to give quick starting in cold weather. So what are the advantages? So first is burning and second is vaporization. So gasoline is a mixture of hydrocarbons such as paraffins, so, such as paraffins, olefins, naphthalene and aromatics. So the composition depends upon the nature of crude available and method of refining process utilized. The boiling range of gasoline lies between 30 degrees Celsius and 200 degrees Celsius, and the specific gravity lies between 0.7 to 0.78. The calorific value of typical gasoline is 44 megajoule per kg. So these are the various characteristics of the gasoline which we use today. So to be a ideal gasoline, so what are the characteristics requirement for an ideal gasoline? So let's see the requirement for ideal gasoline. So first it must be easily mixed with air. So mix with air, airflow in the inlet manifold and quickly operate. Second, it must have high heating calorific value. High calorific value. Then third, it must be knock resistant. It must be knocking and detonation. I will explain later what is knocking and what is detonation. It should be knock resistant. Then fourth is it must burn clean and produce no corrosion. So it should burn clean and no corrosion. So there should be no corrosion. It must not easily preignite. It must not easily preignite. So it should not ignite no self ignition. No self ignition. The sixth, it should not form gum and varnish. So it should not form gum and varnish. Then it should be easy to handle. So it should be easy to handle. So it should be easy to handle. Then and eighth last, it should be cheap and easily available. It should be cheap and easily available. easily available. It should be cheap and easily available. So these are the 8 characteristics for the gasoline, requirement for gasoline. Now, if I want to just write the characteristics required for SI engine. So if we are not using a gasoline, if any other fuel you are using, so what will be the characteristics of it? So the following characteristics required for SI engine is volatility. First is volatility. So volatility is defined as tendency to change from liquid to vapor at any given temperature. So the volatility of gasoline affects ease of cold and hot starting, vapor lock, and length of warm up period. So acceleration and power smoothness, hot styling, crankcase dilution, carburetor icing, short and long trip economy, evaporation loss and deposits, and spark plug falling. So this is a requirement for volatility. So the volatility of gasoline must be regulated carefully so that it is volatile enough to provide acceptable cold weather starting, yet not so volatile that it is subject to vapor lock during normal operation. And the volatility of gasoline is determined by two laboratory tests as ASTM distillation test and Reid vapor pressure test. And Reid vapor pressure test. So the desired volatility depends on ambient temperature. Additives are added to gasoline to control volatility according to regional climates and seasons. So here the desired volatility depends upon the ambient temperature. So additives are added to gasoline to control volatility according to regional climate and seasons. The gasoline, being a complex mixture of many volatile hydrocarbons, evaporates over a range of temperature. The rate of vaporization increases, temperature increases, and pressure decreases. Gasoline is heated at a steady increasing temperature. Percentage of gasoline evaporated with respect to temperature is plotted. So let me plot. So on the x-axis, so this is uh, vo- volatility, 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 and on the uh, y-axis it is temperature. So on the x-axis it is volatility, and on the y-axis temperature. Now here, if I divide this into three sections, so this is 0 to 20%, this is 20 to 80%, this is 80 to 100%. So this is called front end volatility, this is called mid range volatility, and this is called tail end volatility. So if a volatility is in this range, so it helps in ease of starting, evaporation loss, prevention of vapor lock, ease of hot starting. If it is greater than 20%, then it is long trip economy, prevention of carburation icing, prevention of hot stalling, acceleration and power, engine smoothness, and strip economy. If it is 20, only 20 to 80, then it is called engine warm up. If it is greater than 80%, then heat content, prevention of dilution, crankcase deposits, gum, spark plug falling. So those are the various benefits for different volatility range. So various engine performance characteristics affected by front end volatility, mid range, and tail end volatility are shown here in distillation curve. So now the second quality is anti-lock quality. The second is anti-lock quality. So anti-lock quality. So when any substance burns, it is actually uniting in rapid chemical reaction with oxygen. So they combine and the molecules begin to move, but very rapidly as a high temperature of combustion is reached. In the SI engine gasoline, vapor and oxygen in the air are ignited and burned, and under certain conditions, the extreme heating of the unburned part of the mixture may cause it to ignite spontaneously and explode. And this results in an abnormal pressure rise. And this rapid, uncontrollable burning in the final stages of combustion is called detonation. This is called detonation. And detonation in the combustion chamber sets up vibration of gases, cylinder walls, and other metallic surface, giving a distinct noise or knock. And detonation in SI engine restricts the user higher compression ratio and resulting in lower power and thermal efficiency. So due to this quality, the efficiency will be reduced and power will be reduced, and therefore the characteristics of gasoline should be such that it resists the tendency to produce the detonation. And this property is called as anti-lock property of fuel. This is called anti-lock property of fuel, and the anti-lock characteristics of fuel is mostly dependent on self-ignition temperature, chemical composition, and molecular structure of the fuel. So it depends on three factors. It is self-ignition temperature, chemical composition, and molecular structure. Then the third quality is sulfur content. So sulfur is corrosive element and it combines with oxygen form sulfur dioxide, that is SO2, and consequently it combines with other water combines with water at low temperature and form H2SO3, that is sulfuric acid. So it can corrode a carburetor, fuel line, and injection pump, and sulfur has low ignition temperature, and the presence of sulfur may also reduce the self ignition temperature of gasoline and then promoting knock in the SI engine. So this is also the content quality should be less of sulfur. Then gum deposits. So all petroleum hydrocarbon fuel has tendency to oxide in presence of air and form viscous liquids and solids called gum. So gum is normally soluble in gasoline but tends to deposits in the carburetor and other components of the fuel system, resulting in clogged carburetor passages, stuck valves, and other operational difficulties. Its presence causes increased fuel consumption at slow speeds and idling of SI engine. Normally, antioxidants are added to gasoline to improve oxidation stability. Then the fifth is aromatic content. Aromatic content. So aromatic is a high knock rating hydrocarbon, but it has corrosive characteristics. Therefore, it corrodes fuel supply system made of rubber. Hence, contact of aromatic compound with rubber parts should be controlled here. Then the sixth is chemical stability. Sixth is chemical stability. So quality or gasoline should be stable almost indefinitely if stored properly. And such storage should be in airtight containers to prevent oxidation or vaporized water vapor mixing. So it should be withstand the vapor pressure of the gasoline without venting to prevent the loss of more volatile fractions. And the last is that is cleanliness. So petroleum contains many impurities and hence it must be cleaned during refining process to make it suitable for SI engine before use. And gasoline must be clean and non-corrosive. Uh, and non-corrosive and should not contain dirt, dust, or any other corrosive compounds. So the corrosion can cause pitting on the valve seats faces, therefore can be leakage of hot gases which reducing the combustion ratio. Dirt, grease, water, chemicals all must be removed to make gasoline acceptable fuel. So cleanliness is also a very much important factor. Now let's see the rating of the SI engine fuel. So how do we rate the fuel? Rating of SI engine. So rating of a self-ignition engine, or you can call this as a petrol engine, is characteristics of fuel that determines whether or not a fuel will knock in an engine. So it depends on whether or not will knock in the engine under given operating conditions. And there are different methods adopted for fuel rating, such as first is octane number ON, second is performance number PN, and the third is highest useful compression ratio, that is HUCR. So let's start with first, that is ON, octane number. So that is octane number. So let's start with octane number. So the ability of a fuel to resist detonation is measured by its octane rating or octane number. So the octane rating of any unknown gasoline is determined by matching it with that of the series of reference fuels consisting of the mixture of isooctane and N-heptane. So this isooctane is a low boiling point branched chain compound. So isooctane, there is a compound called isooctane and another is N-heptane. So these are the two compounds. So isooctane is a low boiling point branched chain compound and has a negligible tendency to knock. So its tendency to knock is 0%. So its tendency is 0, and hence it's arbitrarily assigned octane number of 100. So it is assigned 100, and the N-heptane arbitrarily assigned an octane number of 0. So this is assigned an octane number of 0 due to its worst anti-knocking characteristics. So octane rating of a fuel was introduced by Cooperative Fuel Research Committee, that is Cooperative Fuel Research Committee CFR USA. An octane scale was developed, and the quality of any fuel is tested on a special designed CFR engine. Hence, the octane number of any fuel can be defined as the percentage of isooctane by volume in its mixture of isooctane and N-heptane, which gives the same anti-knock characteristics as the fuel under standard test conditions. So, for example, a gasoline having octane number 80, and then it is equivalent in its knocking characteristics to a mixture of 80% iso. If I mix 80% of isooctane and 20% of N-heptane, so that mixture will have the same knocking characteristics as the mixture of having 80 octane number. So the tendency of a fuel to detonate varies in different engines and in the same engines under different operating conditions. The octane number has nothing to do with the starting qualities, potential energy volatility, or other major characteristics, and the compression ratio increases with octane number of the fuel. Therefore, it helps to improve thermal efficiency, power output of the engine. And engines are designed to operate within a certain octane range, and performance improved with the use of higher octane fuels within the operational range. Engine performance will not be improved if a gasoline with the octane rating higher than operational range is provided. So this is the information about octane number. So CFR community has standardized two methods to finding the octane number rating as CFR research method and CFR motor method. So that is CFR CFR research method and CFR other is motor method. CFR research method and CFR motor method. So both the tests are carried out in a laboratory on a single cylinder, overhead valves, 3-ball carburetor and variable compression ratio engine. The research test is carried out under relative mild operating conditions, low engine speed and low mixture temperature. And the motor test is carried out under more severe operating conditions, high speed engine and higher mixture temperature, in which more chances of knock being produced. octane number determined by the research is called research octane number, and that determined by motor test is called motor octane number. So the SI engine used in automobile are run on the road under variable speed, load, weather conditions, and different spark type timing, while RON and MON are determined at constant speed, full throttle, and fixed spark timing. Therefore, there is a need to define a road octane number, and the road octane number RON is taken as the average of both the RON and MON divided by 2. So average is taken of the research and motor octane number. Since motor test is less severe than the research test, gives lower octane number for the same fuel, and hence MON is less than RON. So MON is less than RON. So the difference between this RON and MON is called fuel sensitivity. This difference, sorry, this will be the case. So the fuel sensitivity is equal to ROM minus MON. This is the difference is called fuel sensitivity here. So we will see other topics in the next lecture. So thank you very much.